So hello everyone. In the last video, I have seen about the CIFAR dataset and the practical implementation, how to write a code in the using the Pylearn to machine research library. So storage classes, the various classes, the classes, how to handle the exception, train the model, testing, error exception handling, the counting, and the finally how the main function is called. So in the current slide, we will tell about the example of soft math regression using Pylearn 2. So if we talk about what is a soft math regression, so basically soft math regression is a type of classification model, and the regression is the main name. Uh, the completely makes a soft math regression, which means a pattern recognition algorithm that maps the input pattern to the final category. So in this tutorial, so basically tutorials software regression, the input pattern will be the image of handwritten digit, and the output category will be a digit. Okay, the so 0 to 9 and a digit identified. So it's a basically a digit recognition or character recognition, the pattern recognition. So let's define some basic terms. First, say x is the input variable and y is the output variable. And suppose y is between the value of 0 to k. The k is a number of category that x may belongs to. So in this example, if we are classifying the handwritten digit in their value between the 0 to 9, so the y value is very easy to interpret. What is the y? Y is equal to 7. It means the category 7, the category identification is 7. The most application that we accept, okay, being a numeric code identifying category, the number plate or number plate, say, uh, number plate recognition system. So if 0 to 9, it means the various values, various, say, output value that are bind to these values, say 0 to get, 1 to go, 1 to go, plane, etc. So basically, it may be that 0 to 9 various category of the classes are defined in this. So basically, software is a classification model, and in this current video, we will say that okay, how using a software regression model, uh, we will see the output, how to find the output, what is the step between using the Pylearn 2 model. So if we take the example, if we find the Jupyter notebook, so if we take the Jupyter notebook, so we will take that, okay, it's how the software regression in the numerical model. So what is the particular model software regression or the mathematical thing beyond the software regression? So basically the maximum likelihood estimation, how we find the maximum likelihood, and the basic theory to how the software regression training works. So it's basically how toward the working, what is the software integration, and how we category the y output of model distribution. It's a probability based models there. So maximize the probability using that labels of classes. We maximize this function J, and it's a combination of everything three parameter dw and dv is the bias of bw the weight, and p is a training example that are d. So J is a dwb, and multiplication summation of the probability of if x is given, so what is the probability of y, the conditional probability maximize this function. So it's basically the maximum likelihood would be estimated that from the problem, that's the problem for overfitting, and easy stopping or early stopping is a criteria that we have to prevent from this. So we have to minimize these function as a is the product of sum of product, SOP or POS. It's a non-real conjugate gradient descent. We have to minimize the minus. We have to minimize the minus j, and for differential algorithm we can maximize j. So that is the basic difference between how to maximize maximum likelihood estimation. So if we want to use say Pylearn 2 things are there. We have told already about the turn on. We have to train our model on MNSI data set. So MNIC dataset, if we talk about the MNIC dataset, so this is various linear classification for the various linear classification. It's a MNIC databases of handwritten images. Uh, Google Lab, Microsoft Research, these have make this research library, and these various algorithms base the classification base the K-NIST, Neighbor, L3, L2, L1. The data sets are available, and what is the test error rate. the classifier, processing things, and attach data, right? And on top of it, there is a train and images data set are available. That's about 991, 991,000 something like that. And given the 6,000 example, and where's test of this 10,000 and 50,000 for the tree. So, uh, if we talk about say what is this things are there, what is this uh, works are there. So using the MNSIT dataset, we will train our model using the MNSIT dataset. In which, so first thing we have to find that okay, if we have to import Pylearn 2 and these directory, the software regression, this directory, we have to set the path of this directory, and then we have to finally describe this that we are stopping and train stop the 50,000 item and data set and an analysis data into the 60,000 example. So to start and to stop condition we have decided. So again about the hyperparameters that the data set divided by modular by hyperparameters and print the data set. So stopping condition are defined this in the data set of data.ml, and then there's a configuration that how the configure of the file to software regression model. So that regression that is software things are there. Now finally the matrix V that WB randomly initialized. So how to find many categories of the classes that end classes of a data set. So MSIT dataset contains these 20 by 28 grayscale images, but it's not a vector thing. So a vector images means a vector contains 784 element basically. So finally that okay, so the directory name is a directory path set. We have set the directory path, and that the the model, the CDM model, softmax regression model, that training in convex optimization, it was a convex optimization problem. So model is taught about the reading part, that read a data set, that is a model of the YAML, and this print the this model things to initialize between the final range between this. So convex is a training, regression training is a convex optimization problem, and we can initialize, we can still arrange to the initial weight to 0 from other model defined a different type of weight. So next is how to train our training Pylearn to training algorithms model. So it's about the code that how we learn about the Pylearn 2 model. So best size, the value distribution criteria, okay, best size is this, and the hyperparameters are defined. The algorithms are defined, and the stopping criteria, the start at 50,000 is stopping. Okay, the 60,000 maximum limit of this. So we train our model that algorithms that are reading part of this. Open the file directory name. Open this directory name that I have made this dir name. Sorry, dir name. So open this with this .yaml, and then read and then batch the stopping criteria, and then finally test train things are there. So this is basically about the training, how we train, how we set up a Python to training algorithms in this. And the next step is about final step is about the training with Python 2 script and run to the output. So it's about that things are there. Okay, the train things are there. Train dot locals, and the locals. So basically, if we talk about the locals, what are the local things? What are local? So in this, it will save a copy of this mode, some base save as the extension, and we use the train how to define the references use within the train to algorithm section. So it's basically to run the training, how to run the training with the Pylearn to train script, and the script and the interpret is final output. So that's the directory name. Again, directory name is read and save path, which path is to train, and the final training is done. So execute the cell below, and then the final is the YAML strings, this YAML string, So Pylearn2.training.bgt.bg. Final things, the best size availability, the start stopping conditions are there, and then the termination criteria, all the termination criteria, data monitor based termination channel name, the channel name is about defined. Okay, that's the monitor based save based it will check a specific channel decrease, also it will take copy of the model. So this is all about how to train the Python to script and interpret its output finally. And then if it all about the okay, the next execute the next cell to train the model. So if you final train the next cell, take a few minutes and the output final comes. So Python 2.yaml the pass to construct the train object, final train object. And train object and run its main loop until final implementation of okay, that's the Python 2.train.py. And on the GitHub, if you see the GitHub final code of this Python 2, so it's basically the train things as automatic regression code. And if we is it clearly mentioned, okay, that finally the learn find on train.py. So if we talk about the final.py, so it's a YML algorithms file, it's a regression directory that we have saved. That's the software regression dot final lib, and the dataset .yml, the senior dataset part.yml, the YML file that we presently open. It's the objective of the MNIST dataset, and the trainer stock conditions are there. So, and that's a training and model, and finally we get the output. So the monitor channel are the which monitoring channel we are using, and testing and training conditions. So compiling scan the graph size in the modeling epochs, how many the test objective, the train objective, then the next monitoring the clock size scene, the batches scene, the time of epochs, and the final output accordingly. The epoch scene, the every time is epoch scene, the next time the epoch enter. There are examples in this two like examples, and the average gradient and the step size and the white color max mean. So in each epoch, the maximization thing, training and valid final things are there, and then like we see the last epoch, say epoch number 8. So we can see that okay, this is the best size, and this example C, it's the 40, and the average gradient multi-descent, and these things are available. So epoch 12 is time is taken. If time taking things at the 48.40 and the 48 time is decreasing, or the every epoch in the when the example seen as increasing. So training is better, and the final how to analyze the result, that okay, set a misclassification rate and software relation to dot, because .pkl file. So misclassification rate is 0.007. It's a misclassification rate. The epoch size is finally in the case of say epoxy in the 9 times, when within the 9 times. So it's basically how we train a model, how we use a basically about the how you use the Python to how you train a model in the problem in the software and regression, then the directory YML, what is the YML file, the Python dot word name syntax and local directory, the base the what data and model training algorithms are there, and that's which classes is use conjugating means best size. So how we learn using the how set the Python to training algorithms, and the basic things about that, how to lead a Python to specific to the load to the memory data set. So whole things about how works basically works on the basic of things. So thank you so much for this, and to keep watching.